All right, let's get started, folks. Good morning, good afternoon. My name is Nicola Kabar. I'm a solution architect here at TERA, and I am joined by Mikhail Shapirov from AWS. And today we'll be going over how to secure and troubleshoot your microservices on EKS with Calico. So just a couple of notes on the format of this webinar. We'll be spending kind of the next hour or so between walking you through some of our quick overview of the Calico itself, Calco Enterprise, an overview of EKS and specifically network kind of design consideration on EKS, and then we'll kind of switch over to talk about two key areas that we have seen a lot of our users, EKS users, as well as Calico users kind of struggle with or kind of have challenges with around securing their applications with enterprise security groups, as well as troubleshooting those microservices. So those are the kind of two key topics that we'll be kind of going through, as well as a quick demo of Calico on EKS. Feel free at any time to raise any questions in the Q&A section, and we will be happy to answer those in line, or if we have time towards the end, we'll be happy to answer those interactively as well. This session is being recorded and will be posted, along all the other sessions that we've been going through, under the TERA events, and will be also uploaded to YouTube. So if you ever want to go back and rewatch certain sections or brush up, you will be able to do so. Again, thanks for joining us today, and so let's kind of move forward. So let's first start by walking you through a quick introduction of Project Calico for those who have not kind of learned a lot about it or you don't know much about it. But Project Calico is a community-driven open source project that was initially started around the same time as Kubernetes, kind of help define the spec for the CNI, as well as the network policies spec. So we're it's a vibrant community around Project Calico itself. It's open source, and you can use it. And it's becoming kind of ubiquitous when it comes to the becoming a default CNI and network enforcer for Kubernetes workloads. Why a lot of users out there have been using Project Calico, because it's simple, secure, and scalable. One of the things that architecturally the design of Calico itself is uses native Linux data plane performance and creates kind of layer 3 networks without any encapsulation. That's one of the options in which Calico runs, and that way it can provide a simple, scalable layer 3 network for your Kubernetes workloads. In terms of industry standards around it, we have been adopted by all the major cloud providers out there, especially AWS, in terms of the being the default network security or network policy enforcement, and work very closely with our partners, Michael being one here who had joined me today, on a lot of our customers who are using AWS, specifically EKS, and helping them through their design and kind of implementation of Kubernetes and to kind of run their microservices-based applications. We have, in terms of real-world production, today we are familiar with more than 150,000 known clusters that are running Calico out there today across the clouds and on-prem. So we're trusted by a lot of users out there who have been running with Calico, running their kind of mission critical applications with Calico. Now let's kind of switch and talk about Tigera as a company. So Tigera is the company behind Project Calico. We're kind of the inventors and maintainers of Project Calico, and co-led also some of the initial upstream initial kind of collaborations to create Istio as well. And we have a product line solution called Calco Enterprise that is trusted by top kind of Fortune 500 companies and enterprises out there. You can see some of them here who have been using Calco Enterprise to secure their workloads today. So just a quick kind of view of what Tigera does. And I'll switch it over to Michael, who will be talking more, kind of walking you through AWS's EKS. Feel free to go ahead, Michael.
Oh, thank you, Nico. Hello, all. I'm Mikhail Shapirov. I'm a senior partner solutions architect in the container segment at AWS, and I'm very excited to be part of this webinar from both personally and as an AWS employee. I have to say that I appreciate greatly the contribution, both community as well as on the enterprise side for Project Calico. And the objective for this webinar for me is to show you what AWS has to offer to run containers, specifically with Kubernetes, as well as highlight some of the network security general concerns where customers may benefit from a combination of AWS services and partner solutions such as Calco Enterprise. So let's drill down into Amazon Elastic Kubernetes Service, Amazon EKS, which makes it easy to deploy and manage, as well as scale your containerized applications. Next one, please. So, according to the recent CNCF state of cloud native, 68% of cloud native developers that participated in survey use AWS, and that's going to be a combination of our ECS and EKS, and close to 30% of Kubernetes deployments are running on EKS effectively. So while it is surely a great data point, maybe more on the marketing side, the important part, in my opinion, in this statement is that keyword cloud native developers. And cloud native development in general is governed by a number of principles to which I can relate because my background is both engineering. I used to be a senior software engineer at AWS as well as a solutions architect. And in the past, I was different roles as well as enterprise architect, platform architect, and chief architect. So I can relate to the overall topic of what it means to secure your microservices, both from inside, like being an engineer, and from the outside, being an architect trying to establish some sort of governance on top of it. So those principles that govern cloud native development, one of them is practice defense in depth. And the other one is favor managed services, which is what AWS is about. Next one, please. So how customers are using Amazon EKS? There are definitely a lot of use cases. I don't think it's going to be any surprise, but just basically show the connection between the use cases and how it relates to Calico and network security as a whole. So number one, microservices. It's a very overloaded term. So the question nowadays is probably who doesn't use this architectural pattern. However, there are differences in workloads that may drive security and networking requirements. We are exposed to a lot of customers and partners. So some of the use cases that may present requirements for high performance networking on EKS could be video streaming applications. They require UDP protocols, lower layer communications, both ingress, egress, telecom industry, more complex architectures. Customers want to have multiple network interfaces on the same pod to segregate traffic for control plane, for data plane within their applications, etc. So as you can see from the networking perspective, requirements may range from sensitive to internal network performance, which is reasonable. I mean, no customer ever mentioned that they want less performant network CNI, to supporting of multiple network interfaces on the pod. The PaaS use case obviously will present a requirement to segregate your tenants. If it is a platform as a service, then most likely you're going to have, at the very least, hospitable tenants, or in some cases it may be non-hospital tenants, and you need to really segregate network visibility for those as well. Enterprise application migration, and the most recent one is machine learning. We see a lot of adoption of machine learning applications, and that has its own flavor. There is a way to train your models on one hand, and then you need to be able to share those models with probably other teams that may run in the same cluster or other clusters for inference, etc. So those are some of the common use cases that we observe. Next one, please. So Amazon EKS is based on a few tenets that we adhere to. And number one, it is Kubernetes. And number two, it is upstream Kubernetes. Basically means that whatever you install locally as vanilla Kubernetes distribution is the same distribution you're going to get with EKS. But what is the reason for having this service? So number one is managed service, obviously, but it is also integrates with various services from AWS, and those services are like starting from IAM integration, roles being part, integrates with our service accounts. We integrate with VPC, we integrate with load balancing, etc., and all the services around that because of that. And the last one, but not the least, and probably is the most important, is that EKS is designed to deal with production workloads. And that means that it is highly reliable. And frankly, I can attest that AWS engineering practices, as far as operational excellence, are just amazing. And in combination with high availability instruments that we have in our portfolio, like availability zones, etc., you get a very reliable service. Next one, please. And that is one of the reasons why customers choose us. We are very conservative with that kind of numbers, and it's 99.9%, 3 nines for the service level agreement. That is a very conservative number, and normally, you probably should expect much better availability from multiple perspectives. But if it falls below that, you will be eligible to receive a service credit. Next one, please. And let's talk a little bit about EKS architecture. I just mentioned that it is upstream Kubernetes, so is there anything different about it? So, and this is a very simplified diagram, and does include some of the additional extensions that we have, such as Fargate, but it's good enough to depict the overall state. So the biggest difference is that we have a separation between the control plane and the data plane. And the control plane, basically it is etcd and those components that are part of Kubernetes, but no customer wants to necessarily have direct access or manage it. And that's why it's running in a separate account, effectively, and that account belongs to AWS. And the data plane consists of the worker nodes that actually run your pods. And that part is visible to you, and it's running in your customer account unless you use Fargate, which is yet another flavor of this architecture. The control plane itself is managed by AWS and is fairly inexpensive to run. Plus, you can see that AWS is responsible for high availability, distributing those components between different availability zones, making sure everything is highly available. And that's, I think, is a great help to anyone who wants to run Kubernetes in the cloud. Next. Well, let's talk a little bit about VPC CNI, which stands for Container Network Interface. It's AWS one of the first contributions that we made to the community was the CNI plugin that allows Kubernetes users to take advantage of native VPC networking for their Kubernetes pods. And we do adhere to certain tenets. There are multiple CNI providers that we support with EKS, but our native CNI provider integrates your pods with our VPC networking and make them first-class citizens on the VPC network on US subnets. And it is simple and secure, plus it is open source, and we accept contributions. We are very transparent about how it is done. In addition, it provides certain integrations to our security controls, such as security groups, although in a limited way, which we're going to talk a little bit about later. So next one, please. So we do adhere to certain networking tenets that are common for any Kubernetes CNI implementation. Well, number one is all containers must be able to communicate with all other containers without natting, so there is no source translation. And all nodes should be able to communicate with all containers without NAT. And the IP address that a container sees itself as is the same as the IP address that others see it as. So there are no intermediate layers in between them. As I mentioned, containers are first-class citizens when they're running in Kubernetes, and they get the same network interfaces as virtual machines from EC2 or anything else. So in general, CNI is referred to as a single component, but in reality, it is basically just a very thin wrapper, which is the actual CNI plugin and implements the CNI contract for Kubernetes. And there is a network control plane, normally is implemented as a daemon set running on the Kubernetes cluster. And that part, the control plane, is responsible for IPAM, which is IPs and RAS management, so creation of those IPs and integration of networking with VPC. On this diagram, you can see that we have an Nginx pod and a Java pod allocated. There is an ENI, which is Elastic Network Interface, that we attach to those pods. They create a virtual Ethernet device on those pods, which effectively creates the network interface. And they get an IP address, which are attached as secondary IPs to that ENI and effectively to the node on which that specific pod instance is running. And a similar approach is happening on all the nodes. So that's how we ensure communication. But on top of that, just a little kind of like background on what's really missing here is that some of the security mechanisms that are part of EKS and come out of the box may not be sufficient, and we don't necessarily provide support for network policy enforcement with our AWS VPC CNI plugin. And that is the area where we look to partners, and specifically TERA in this case, and projects like Project Calico. Next one, please. So let's talk about security tooling, and security tooling and security is job zero at AWS. Very obsessed with that part, and we provide so many controls and products and services around security. We view security as the kind of like an onion layered architecture. There are multiple perimeter level controls as well as internal controls that customers can apply. Starting from Cloud HSM, you can use KMS for key encryption. You can use Guard Duty, which is a threat detection service, continuously monitors for malicious activities for your AWS accounts, workloads, data stored in S3. You can see ACM. If you need the TLS protection, you need a certificate manager that's also built in, and we have public certificate could be used for free with AWS as long as they are within AWS environment. Security Hub, IAM, which roles, permissions, policies, permission boundaries, etc. CloudTrail for audit control, WAF, Secrets Manager, and Macy, which is also a machine learning driven service to provide to discover vulnerabilities, deviations from best practices, etc. But the thing about all of those tools, the way I look at them, is that all of them are basically kind of like on the perimeter of your Kubernetes cluster. So the question is there anything that can be also part of my Kubernetes cluster inside my Kubernetes cluster, especially when we're talking about interaction between containers or between the pods within that cluster itself? Maybe you have multiple namespaces and individual development teams use those namespaces for their workloads, etc. So can we have controls that can enforce the rules, maybe in a centralized fashion as a governance approach, to kind of secure the cluster itself or multiple clusters to that extent? And that approach should also be Kubernetes native. It should be very good to go with infrastructure as code applied through CI/CD pipelines, etc. Next one, please. So, and that's where we have those networking and architectural considerations that I'd like to talk about. And one of the glaring questions on the VPC CNI is that all those secondary IPs on the NI, those IPs that, as I mentioned, are allocated to individual pods, they share the same security group as the security group configured at the ENI level, which is effectively the security group of your node in the default configuration. So whenever your pod is talking to anything outside of itself, to any other pod or any other service within AWS or even externally, it's going to be governed by the security group that is assigned to the node. And that level of granularity may not necessarily be sufficient because at the end of the day, each pod may represent a deployment, which is a specific app, and each app should have its own set of constraints. And that's where we look at TERA and Calico to apply Kubernetes native approach, network policies, which are very convenient, as well as we can probably discuss a little bit about maybe deeper integration with AWS security controls, such as Security Group. So with Calico, you can enforce a policy, you can implement network segmentation, you can implement tenant isolation. It is useful for multi-tenant environments where you must isolate tenants from each other. Network policies, in a way, are similar to AWS security groups. They are maybe a little bit, more Kubernetes native, but the essence and spirit of what it's trying to achieve is the same. So at present, network policy is limited to layers 3 and 4, and that basically means that you are restricted to IP ranges as well as ports, but nothing beyond that. You cannot apply layer 7 based restrictions such as I want them to access this HTTP URL but not this path, etc., but which may be coming, that what customers may be interested in. Customers may also be interested in FQDN level restrictions as opposed to saying this pod cannot access this external IP, I want to say that this pod should not be able to access some website domain name with wildcards, etc. So those are some of the areas of development. And on the observability side, obviously we expect visualizations, we expect detective controls and troubleshooting, which hopefully Nico is going to show you visually how it is done with microservices when it comes to troubleshooting of networking issues, etc. And on the operations side, customers have a very heterogeneous landscape of what kind of workloads they want to run, and some of our customers are running Windows workloads quite a bit, along with Linux workloads. So that becomes a very important aspect, and cost of this whole total cost of ownership of the production cluster or the full infrastructure is also a very important aspect from the network and from the architectural consideration perspective. Next one, please. So with EKS, we provide a number of alternate compatible CNI plugins. The keywords here is compatible. That means that AWS did some work to ensure that all of the mentioned providers are compatible and can run with EKS. I personally was involved helping with that effort, and which ultimately resulted in this page. And recognizing that CNI installation and Calico in particular is an important part of a production-ready EKS cluster, and by that I mean not only production for workloads, but production-ready for development clusters or testing or whatever you have. AWS has created this page, and there is a reason why Calico is the first entry. It contains also instructions to install and configure Calico with your EKS cluster. And you could try this if you would like to try Calico with EKS, just following those instructions for installation, and it hopefully should be a very pleasant experience for you. Next one, please. Another sign of recognition of the project Calico and Calca Enterprise is inclusion of this product and this solution within our EKS Workshop. And EKS Workshop is probably one of the most popular workshops for EKS. I mean, I used it myself, both as an attendee and a person who delivers it. And we have a whole chapter on configuring your network policies. And within that workshop, we call out Calca Enterprise for the beginner level. So effectively meaning that regardless of anything that you do, it is important to have the network policies installed. Like a best practice, you need to configure a network policy that denies everything, and then just specifically allow specific endpoints to, whether it comes to a namespace isolation or specific pod-to-pod communication as the need comes. So basically going to a whitelisting approach. Next one, please. And in addition to that, my fellow container solutions architects have created this webpage. It's called Best Practices for EKS from the security perspective. And as far as network security, we do call out Project Calico as one of the main mechanisms to enforce network policies. Along with the detective controls and everything else, it provides a very mature and safe infrastructure from the network perspective. Next one, please. And another one that, as I mentioned, that from our customer workloads, we have a very heterogeneous landscape, and a lot of customers may want to run Windows containers as well as Linux containers. And for those customers, it is also very important to make sure that whatever CNI solution that they're using for network policies should work with Windows. And recently, I think it's a fairly recent blog post that is referenced here, There is support for Calico with Windows containers, which you can also take a look at this blog post and give it a shot. All right, I think that's all from my side.
Thank you so much, Michael, for that overview. And I'll switch gears to kind of focus the discussion now that we have a good understanding of EKS and the different kind of networking options that you have on EKS. As Michael mentioned, there is still quite a couple of challenges when it comes to running your microservices on EKS, specifically around how you can ensure that there's the right set of security controls, as well as how to ensure that you have the right set of visibility and tooling to troubleshoot any issues that may arise when you run those workflows on EKS. So let's talk about those kind of two challenges. But first, I want to kind of remind you that from the CNI perspective in Calico, as Michael mentioned, you have the option to run Calico as a CNI, also as a network enforcement for Kubernetes network policies on EKS, but also Calico Enterprise as a solution, an end-to-end solution to manage your network policies, gain that level of visibility into your workloads, can also run across pretty much all Kubernetes solutions out there, specifically EKS. So the three key areas that Calco Enterprise focuses on beyond what the Calico CNI and network enforcement does are around security controls, access controls, and visibility and troubleshooting. Those are the features and functionalities that and the use cases that we address in the enterprise solution that is Calco Enterprise. So the first use case that we're going to discuss is, let's say you have, or you're going to start building your or designing your EKS cluster. You have a subset of applications that you're kind of interested in onboarding to your EKS cluster, but you want to ensure that there's a set of security controls, whether those are based on your existing measurements, or existing measures, or processes that you have been developing for your existing applications that are not containerized, and you're moving those to container-based applications and microservices, or if you're coming up with net new security controls for your cloud-native applications. So if we look at it, kind of the challenge that is presented here when you want to take existing security controls and move them as they are. Of course, we all know that containers are ephemeral, and the IP addressing that come with them is also dynamic, and therefore just using existing security controls, and even as great as the security groups are in AWS, still they will not be sufficient because we're talking about a lot of pods running on the same nodes, and across different nodes. They could be belonging to the same tenants or even different tenants, but they will be sharing various levels of the underlying infrastructure, the EC2 instances and other resources. So that's kind of the main challenge. Additionally, from a visibility and auditing perspective, you want to make sure that as you are creating those security controls, that either segment certain applications and microservices within a specific namespace together and make sure that they can talk between each other. You also have a set of reporting to ensure that you're doing so correctly, and ensure that if there's any issues with those policies or any violations will be reported and audited as well. So we all know that in the world of Kubernetes, a lot of the labels and selectors are really come in at core in terms of how you actually can group applications and pods together and services together, and how you can actually select them to be used when you're applying policies. So This is nothing new here, but making sure that you have the right set of labels for your applications, and then using selectors when you're creating those policies, an extensive set of policy definition available in Calco, and full visibility into those policies is really critical. Now, one key thing that we're seeing a lot of for our customers who are kind of want to make sure that they have this uniform way of applying policies, regardless of this, the namespace or the project or the application that sits on top of it. So there've been, a good way to apply that is using the tiered security policies, which basically gives your SecOps or InfoSec teams an ability to apply and create and apply policies that will be applied across all the workloads for this kind of uniform policy definition and enforcement. And then, other tiers, being the application or the owners of the application, can then come and actually define their own set of policies to ensure that their application behaves as expected. So combining kind of the power of tiered security policy with the normal definition of how you create policies, it can be pretty powerful when it comes to applying those enterprise security controls within your EKS environment. First, an easier way to manage those policies, out of the box, you can create some of the policies, both Calico policies as well as Kubernetes network policies. What Calco Enterprise does here is it enables both admins as users to easily manage and visualize those policies and collect metrics along what had been allowed, number of packets and bytes that have been allowed or denied per policy, and have a single pane of glass for managing those policies from a single place. And as I mentioned, another key factor in defining enterprise policies is around compliance reporting for your networks and network securities for your Kubernetes cluster. So what we have out of the box is a set of compliance reports and dashboard that can be run at a frequency that you can specify to summarize what had been, what endpoints, what pods had been protected, export kind of the detailed data around, around those, as well as, number of running also CIS-based reporting and ensuring that the network and network security, security measures are actually enforced. And that can be very critical, especially in some of our customers who are, in highly regulated or compliant environments, that they need to make sure that those sets of compliance requirements are met. And of course, every single either API, CLI, or UI interactions, is logged. So if users are using the platform here, or its admins are using the platform here, they can, every interaction is logged with, clear definition of what had happened at the specific timestamp, and also you can get all the, a version history of what are those changes and who made those changes. So that's one key area around, enforcing security controls within your EKS cluster. And let's switch over to kind of the second key pillar here, which is around visibility and troubleshooting. So the lack of visibility into Kubernetes is, can cause a huge amount of, headache in terms of troubleshooting those applications when they go down. But not only that, the biggest loss is actually when you start losing revenue, or there's a cost associated with an application going down. Now, we all, especially when it comes to microservice-based deployments, we know how critical the network is, because those services are going to be relying on a robust and secure network to communicate, whether they're running within the same environment, same EKS cluster across multiple EKS clusters, or even communicating with other services running within AWS. So connectivity issue can definitely be problematic for a lot of the developers, and even especially for the SREs right now. So the platform needs kind of a way to pinpoint the source of any connectivity issue rather quickly and avoid connectivity issues well in advance. Now, I mean, that's basically another slide that kind of summarizes, how a lot of the users who are just kind of defining policies and just start seeing some issues, network connectivity issues, but there's no way to pinpoint those issues easily, especially when you're using existing tooling that is not specific to Kubernetes. So one of the things that Calco can help with here as you can onboard your application microservices into EKS is the ability to collect a richer set of metadata around each flow within your environment. So not only do we collect the traditional 5-tuple kind of data points around the source and destination IPs, but as you know, those are going to be dynamics, and there's no easy way to pinpoint those to the actual application and the pod and so forth. So we collect those, but also we collect the source and destination pod names, service name, namespaces, labels, and of course a policy that is going to allow or deny that traffic. And all of that can be not only shown visually within Calco, but also can be exported to Security Hub and any other logging platform choice, so that you can actually respond to any incident if you wish. If you have an existing CM tooling to create and respond to incidents, the level of data that you provide can be truly extensive here. So, aside from the source of data itself that I described, we actually provide an easy-to-use visualizer that helps you as a user and you as an admin to understand what is the traffic profile that is that defines your EKS environment, which application and services are talking to which application services. You can drill down and examine those workflows, understand the network behavior that is going on. Now, that is an easy-to-use tool that can truly kind of reduce the time it takes to find out those issues and find the root cause of those issues. Another measure that we bring to EKS users here is how you can, today with the EKS, you can of course create Calco or Kubernetes network policies, and then be able to run, just deploy them if you have the right set of RBAC. You're authorized from an RBAC perspective to deploy those network policies. But if you have a large set of applications with a lot of users who are using your environment, there needs to be a better way to operationalize the full workflow of creating, staging, and updating, removing all those network policies. So what Calco Enterprise provides here is a mechanism to visually create or even use our recommendation engine to create those policies, stage them, make sure that you understand, collect telemetry on what's going on with those policies. You can also preview them, and we compare the policy, the impact of the policy compared with real-time network statistics that we gather, so we can tell you exactly what the specific policy is going to introduce, any blocking in the traffic, so you can actually avoid that. And of course, if you make any updates, we audit that and log that all within one place. So those are the kind of key Calco Enterprise benefits. As I mentioned, especially when it comes to visibility and troubleshooting, you have an end-to-end visibility into your network across across your EKS and EKS clusters. You have Kubernetes context-rich flow logs that you can either use Calico to explore, or you can actually use Security Hub and ship those logs to a Security Hub or any other platform that you use, as well as the detailed network policy workflow that enables you to use RBAC to define a truly kind of enterprise-ready network policy workflow around your, creating and managing your network policies. I'm actually I don't think we have quite the time for the demo here, but I want to leave some room for actual question and answer, because I see there could be a few. But just to kind of summarize a couple of the, things that we mentioned, Mikhail and myself. One great resource to find all things related to Calico on AWS is to head to Tigera.io/partners AWS, and we have pretty much a lot of resources there around the webinars that we have, the customer interviews, and other resources that you have around AWS as well as Calico. If you have never tried Calco Enterprise, feel free to use Tigera.io/trial. We actually provision a full EKS cluster for you, and you can poke around, the Calico Enterprise features, and you can play with. We do a couple of labs that showcase a lot of those areas that we discussed earlier today around policy definition, previewing, staging, access controls, auditing, and so forth. So if it's an easy way to get your hands familiar and get familiar with Calico Enterprise on EKS. Also, Mikhail and I would definitely recommend, if you haven't already, to go through the Amazon EKS Workshop. It's kind of an open source and highly helpful workshop that you can use to run through a long set of guides to provision and use EKS, and use kind of the best practices around EKS and get familiar with it as a platform. But there's definitely a big section there around network security, and you can see there that Calco and Calco Enterprise are part of the EKS workshop. So it would be great if you want to, if you have your own environment and you want to set it up, set EKS up, and play with Calco as well. Feel free to use that as well. It's a great resource there. With that, I would like to kind of wrap it up. I really appreciate the time that you've given, folks. As I mentioned, this was recorded and will be posted. We'll be taking some questions right now from both the Q&A section here, but also interactively, since that we don't have a whole lot of people. So feel free to ask myself or Mikhail any questions that you have. And a big shout out for Mikhail. Thank you so much for this collaborative work to talk all things Calico and EKS. So
thank you, Nico. Likewise.